Hello. Today, me, Jada, and Chris are presenting our research on the effectiveness of a do it yourself DIY air cleaners in improving indoor air quality. We know of their impacts on student health and cognitive performances. So, you may know about the recent wildfires and COVID-19 pandemic, both of which have impacted us so much and re emphasized the importance of clean air in indoor environments. DIY air cleaners do exist, and one of the most popular ones being a 4x1 design emerged as a low cost alternative to commercial expensive air purifiers. However, in our study, we took this design a step further by proposing a more effective 5x1 configuration with five MERV 13 filters aimed at improving airflow and capturing pollutants from all directions. Moving to our proposed air cleaner design idea.
Our proposed design enhances a traditional 4x1 setup by incorporating five MERV 13 filters, a custom shroud design in AutoCAD with laser cut material of chipboard. The goal was to enhance the airflow and the efficiency of the air cleaner from this design. It allows for faster air purification and attracts contaminated air from all directions, ensuring a more comprehensive cleansing of the environment. We'll talk about the field testing of the laboratory.
So, in order to assess the effectiveness of our air cleaner, we conducted a laboratory test in a controlled household room. We used a method called Clean Air Delivery Rate, CADR, which measures the ability of the air cleaner to remove fine particles such as PM 2.5. So, what we did was inject pollutants into the room using tobacco smoke and dust particles generated by vacuum cleaners. Now, the tobacco smoke also emitted gases like carbonyls and carbon monoxide, which we know could potentially affect indoor air quality. So, after the pollution injection, the air cleaner was turned on. And as you may see from our poster graph, we measured the decay rate of pollutants over time. The linear regression analysis was used to calculate the pollutant loss rate, which helped us determine the CADR. This showed us that our DIY air cleaner had a CADR of 314 cubic feet per minute. This is comparable to the performance of commercial air cleaners like the Honeywell HPA 300. Our cheaper and novel innovation actually does a better performance than the commercially available one. So, another field testing that we conducted was in a classroom.
In addition to laboratory testing, we deployed the DIY air cleaner in a real classroom environment with seven occupants. Before and after deploying the air cleaner, we measured the indoor air quality and collected data on participants' health and cognitive outcomes. The survey focused on environmental parameters like air freshness, odor level, humidity, and air quality. We found that the participants reported experiencing fresher air after the air cleaner was activated. Notably, air freshness and odor level were the most statistically significant factors. However, we also noted that the increased airflow created a perception of drier and cooler air among the occupants, which probably contributed to the discomfort of the colder environment from the DIY air cleaner. The second issue was the noise concern generated from the box fan.
So, in conclusion, we found that our 5x1 DIY air cleaner delivers and demonstrates a CADR of 314 CFM, which is comparable to any typical commercial air cleaners. The participants had reported to experiencing much fresher air, even though noise was a primary concern when we tested this on a high mode. This work, in conclusion, supports the feasibility of DIY air cleaners as a practical approach to promoting healthier, high functioning environment educational environments. Thank you.